Alright, welcome back. So we are still in section 1.3 and we are doing a solving session. In this solving session, yesterday we solved up until number 10. 9. I'm going to do 10 today. Like, look at this. Limit tan x over x as x approaches 0. Again, the first thing we usually try is we try to apply the algebraic properties, which is substitution. So our first intuition is to do substitution before trying anything else. See here, when we try substitution, tan 0 is equal to 0 and 0 is equal to 0. So we see, whenever we see a 0 over 0, this one, there's an alarm. This alarm means we have to do more work because obviously the primitive substitution did not really help. But when we see a 0 over 0, this means that we have a window of hope. What do we have to do? We have to rearrange how the function looks like so that we can cancel whatever is causing a 0 up and a 0 down. So whenever there is a 0 up and a 0 down, it's being caused by the same, if you want, the same مصدر نفسه, يعني from the same source. So we have to go to that source and sort the problem out. What kinds of more work have we learned so far? We have learned that we can, so after substitution, if we find a problem, if there's an alarm, we start thinking of how can we rearrange in order to find the source of the problem. So one of the rearrangements was the simple factoring. It doesn't work here because I don't have polynomials. Second rearrangement was rationalization or multiplying by the conjugate. And we multiply by the conjugate usually when we have roots in order to get rid of and simplify those roots. A third thing that we have learned from before is that whenever we have, and especially trigonometry, two things when trigonometry is available. Actually, three things can help us when trigonometry is available. One of the things that helps us is that the limit of sine theta over theta as theta approaches 0 is equal to 1. So this is one of the options. A second option that works when we're using trigonometry is simplification. You know, most students do not like trigonometry because, you know, it doesn't have one form. Tan can be written as sine over cosine. Cosine can be written as 1 over secant, and so on. So there are so many ways to write the same thing. Cosecant squared plus sine squared can be cosine squared plus sine squared is equal to 1. Tan squared is equal to 1 plus secant squared. You know, these kinds of things are all things that we have to think about when we are involved with trigonometric function. Another thing that can help sometimes, but not in those cases, because here I can tell what the limit is. But in some cases, like remember when we did the squeeze theorem example yesterday, in the cases where we have limit x squared or any power of x actually times cosine 1 over x or sine 1 over x and so on as x approaches 0. This needed the squeeze theorem where we squeezed the cosine 1 over x between -1 and 1 and found the limits of the upper and the lower bun, which forced the filling to have the same limit. So it's good always to have a scheme, to have a plan, to think about what am I going to do, what's going to happen, how am I going to behave with respect to this. See, for such an example, whenever tan is involved, sine is involved. Whenever tan x over x, it's as if you are seeing sine x over x. Why? Because if you use some trigonometric information, you will remember that tan x is what? See, tan x over x can always be written as 1 over x times tan x. I do this trick every single time I have a fraction that I don't want to keep as a fraction because I wouldn't want to do sine x over cosine x over x. This will cause for me to have nested fractions, to have fractions that are complicated. An easier thing, so some algebraic hint, whenever you have a over b, this can be written as 1 over b times a. It can be written as a times 1 over b if you want, and so on. So it's very important to realize that whenever we have a fraction, we can really separate them so we can manage one of them in a simpler way. See, when I write tan x over x as 1 over x times tan x, now it's easier for me to simplify and write what tan x is all about. What is tan x? It's sine x over cosine x. And now you see, when I rewrite it as sine x over cosine x, see what causes the 0 in the tan x is the sine x, not the cosine x, because cosine 0 is equal to how much? 1. So if you want to rearrange this, because I can rearrange it as sine x over x times 1 over cosine x. Now this can directly show me what the real limit is. What's the limit of sine x over x as x approaches 0? This is a full package. Limit sine theta over theta as theta approaches 0, or limit sine x over x as x approaches 0, or limit sine u over u as u approaches 0 is always equal to 1. And the limit of 1 over cosine x as x approaches 0 is 1 over cosine 0. But what is cosine 0 again? 1. So this becomes 1 times 1 over 1, and the answer is 1. So you see, when you know how you're heading, this is what I always stress. Do not do things randomly. Just think about what you really need, what you want in order to solve the problem out. Another example, example 11, limit as x approaches 0 of x e minus 2x plus 1 over x squared plus x. Again, we never do anything before we substitute. So substitution is our first resort. So what do we do here? We substitute 0. What do we get? 0. E to the power 0 plus 1 is e to the power 1, which is e, over 0 plus 0. The answer is 0 over 0. See, when I have polynomials, the first thing I think of is I factor. And what is really causing the problem, as I told you yesterday, so again, keep on reminding yourself of that. If when I substitute 0 in a polynomial, when I substitute x in a polynomial, I get the answer of 0, this means I can factor x minus 0, which is x. See, upstairs, I have it factored already. What do I only need to do? I need to factor it in the bottom part, in the denominator. Can I factor x in the denominator? Yes, simply it's a common factor. This x and this x, am I allowed to cancel them? I'm only allowed to cancel a term in a fraction when this term is not 0, but I can guarantee this term is not 0 because x is approaching 0, meaning x is not 0. So this and this cancels, which means that I'm left with the limit of e minus 2x plus 1 over x plus 1 as x approaches 0, which means now I can try doing the substitution again. E to the power 0 plus 1 is e to the power 1 over 0 plus 1, 1. So the answer is E. I always insist, especially now that you are doing this online, I insist that you input your answer as an exact answer. I don't want rounded figures, so you do not change it into 2.73 and so on. No, you keep it as E. E is a very eligible answer, and it's better than any rounded answer that has lost accuracy. Number 12. Limit as x approaches 0 of x squared cosecant squared x. Again, when I try to solve this problem, I will get the limit of x is 0. What's the limit of cosecant x as x approaches 0? What is cosecant x? Cosecant x is 1 over sine x. So at 0, 1 over sine x will be what? 1 over 0. Which is, again, if I rewrite it in a proper form, this is a 0 over 0 in disguise. So I start thinking how to solve this. It needs more work, it needs more analysis, it needs more interference. So I start thinking, which of the options that I have learned works? Does factoring work? What will I factor? It's x squared and cosecant squared x. I can't factor anything. Do I multiply by the conjugate? Of course not. There are no roots and so on. So I start thinking, well, this is trigonometry. In trigonometry, one of my first intuitions is to relate to the limit of sine x over x, or x over sine x. Remember, you can write it as sine theta over theta or theta over sine theta. Both of them have the same limit. So we start thinking, is there a sine x hidden anywhere? Of course. Where is the sine x hidden? Cosecant squared x is 1 over sine squared x. So this is basically nothing but the limit of x over sine x squared, because x is squared and sine x is squared. So it's x over sine x happening how many times? 2 times. But I already know what's the limit of x over sine x as x approaches 0. It's 1. Square the answer is 1. So you see how you use all the knowledge that you have learned so far in order to be able to manage such problems. Look at number 13. Limit as x approaches 0 of root x plus 4 minus 2 over x. Again, I don't want you to solve anything before you do the substitution. You cannot call the fire department before you prove there's a fire. See, you cannot call for more work strategies before you show that there's an alarm. There is something that is not happening the way it should be. So in order to do that, I do the substitution first. 0 plus 4, 4. Root 4, 2. 2 minus 2, 0 over 0. See, when I see it, I know that this is my alarm. I need to do something about it. So I start thinking about my options. Directly the option is clear in front of me. What do I have here? I have a root. When I have roots, what do I directly think of? I think of multiplying by the conjugate. What's the conjugate of root x plus 4 minus 2? It is root x plus 4 plus 2. I never multiply by something only on the top, because then I will be changing my function. So I have to multiply by it up and down. And then this gives me limit as x approaches 0. Why do I multiply by the conjugate? Because conjugates are beautiful. What do we remember when we have conjugates? I have a minus b into a plus b. When I expand them, it's the square of the first minus the square of the second. So the square of x plus 4 under the root minus the square of the second. The denominator, I'm looking again for what term? When I substituted 0, I got 0 up and down. So what factor am I looking for? I'm looking for the factor x minus 0, which in other words is x. I have it in the denominator, so expanding the denominator seems to be a waste of time. Now, this is limit. Square of the square root is x plus 4 minus square of 2, 4. This is equal to x plus 4 minus 4 is x. As x approaches 0. You see the x I was looking for up and down, now it's there. Can I cancel it? Yes, because I'm working with the limit around 0, so x is not 0. And then what do I have left? Many students write that they have left only x plus 4 plus 2. They forget that when they cancel x by x, this means they divided up by x, so they're left with 1, and they divided down by x, so they're left with 1. So you have 1 over root x plus 4 plus 2. Now substitute again, you get 1 over 0 plus 4, 4, root 4, 2, 2 plus 2, 4, and this is your final answer. A quarter. What's the limit of this function around 0? The limit is equal to 1 over 4. There are so many examples. Again, I tend to solve as many as I can, because the more you solve, the better you become. What's the first step that you have to do? Always before calling for help, you have to first prove that there is a need for that. You have to ring the alarm. To ring the alarm, you need to see a 0 over 0, or you need to see a problem. So you need to substitute 2 times 0, 0 over 3 minus 0 plus 9, 9. Root 9 is 3 again. So this gives me 0 over 0. When you see it, this is when you say the algebraic primitive methods did not work, so we need to do more efforts, and we need to apply the solutions that we have learned. Again, one of the things to do is to set a path. What are you looking for? Since when I substitute 0, it caused the problem, then what factor am I looking for? I'm looking for x minus 0, which is x. I already have the x upstairs, so what I'm worrying about is that I cannot see it downstairs. Because I cannot see it downstairs, I need to change the shape of the equation. To change the shape of the equation, we multiply by the conjugate up and down. I do not expand this because this is already factored the way I want. See, I forgot to write limit as x approaches you. So I keep it as it is. What needs to be sorted out is the denominator. So what do I do in order to sort the denominator? This is a minus b into a plus b. The product of them is the difference of two squares. So it's 3 squared minus root x plus 9 squared. I always advise students to put brackets here because let me show you what happens when you miss the brackets. This you will keep it exactly the same. What will happen to most students is that they will do 9 minus, they will forget about the bracket. What's the square of the square root of x plus 9? It's x plus 9. Now come and sort it out, simplify it. What will you get? And this is what many students will do. They will get 9 plus 9, 18, minus x. And this is our problem. They will get stuck here. Why will they get stuck here? Because they did wrong algebra. I'm getting a marker. They did wrong algebra. See, forgetting this bracket over here made us subtract only the x, which caused this problem. Can I cancel the x with the x up? And here students start creating messier and messier answers. Why? Because this is a wrong step. What do you have to do instead? You have to keep your bracket because the minus has to affect everything next to it, everything after it. So when you simplify this and look how a simple bracket, a free bracket, 9 minus x minus 9, and this changes everything because now you have 9 minus 9, 0, it cancels. So what do we have left? Minus x. You see that you were looking for an x, you found it here, you couldn't find it because you have done some wrong algebra. See, when you find this x now, this x and this x, they can cancel each other because you are working around 0, not equal to 0. So what do you have left? 2x divided by minus x is minus 2. 3 plus root x plus 9, which means that when we substitute 0, we get minus 2 into 3 plus root 0 plus 9, which is 9. Root 9 is equal to 3. The answer is 6 times negative 2, negative 12. All right, this is the limit that we've been looking for. Let's look at another example. Again, first step is substitution. I need to see the alarm first. 1 minus 1, 0. Root 1, 1 minus 1, again 0. I saw the alarm. I start thinking in my head, what are my options? What can I do? Well, I'm looking for x minus 1. X minus 1, root x minus 1. What is the best way to do this? I use conjugates. What's the conjugate of root x minus 1? It's root x plus 1, up and down. Many students forget to copy the conjugate up and down. They just do the multiplication here and they forget the upper conjugate, which is wrong. Here root x minus 1, root x plus 1 gives me root x squared minus 1 squared. Brackets help you a lot. Please use them, they are for free. Over root x squared is x minus 1 squared, which is 1. You see the x minus 1 and the x minus 1, which we were looking for. This cancels with this. What do you have left? Root x plus 1 What's the limit of root x plus 1 around 1? As x approaches 1, root 1 is 1, 1 plus 1, 2, and this is the limit we've been looking for. Number 16. Again, what's the first step? Substitution. When I substitute this, what do I get? 4 cubed minus 64. 4 cubed is 4 times 4, 16 times 4, 64. 64 minus 64, 0 over 0. Again, big problem. How do I sort this big problem? I look at the kind of function that I have. I see I have polynomials. When I have polynomials, my first intuition is factoring. To factor, what formula do I have to use? Of course, this is a difference of 2 cubes. This is x cubed minus 64 is 4 cubed. You remember from yesterday what the difference of 2 cubes formula is? This is the formulas that we have covered yesterday. We said that difference of 2 cubes, a cubed minus b cubed, is a minus b, a squared plus ab, not 2ab plus b squared. Okay, do not put a 2ab. The 2ab is when you're expanding this, you expand it as a squared plus 2ab plus b squared. This has nothing to do with this one, so please be very careful with the usage of 2 that our subconscious always have. So here it is a minus b, so x minus 4, x squared plus 4 times x without any 2 plus 4 squared, which is 16. This is the correct factoring over x minus 4. The moment I see an x minus 4 up and down, I can feel relaxed. Why? Because what was causing the 0 up and down? Which factor were we looking for? We were looking for the factor x minus 4. We found it. So now I can say that this limit is equal to the limit as x approaches 4 of the simple x squared plus 4x plus 16, which is equal to 4 squared 16 plus 4 times 4, 16 plus 16 again, which is 48. Another example. This is one of the new examples that we haven't covered something like it before. It's when we have to simplify our problem by again applying algebraic properties that you have learned before, which is addition, subtraction, simplification of fractions. So these are fractions, 2 separate fractions. We need to simplify them. Because if you notice here, I first try substitution, the normal substitution. 1 over 1 minus 1, 1 over 0. 2 over 1 minus 1 is 2 over 0 again. Those are undetermined cases. I don't know what this is. I don't know what 1 over 0 minus 2 over 0 is. In math, we're not allowed to divide by 0 to start with. So if I'm going to divide by 0, and then subtract them, then this is very wrong, of course. So, of course, I cannot answer such a question. This means that the way the question is formatted is not easy to answer. It doesn't mean the limit does not exist, so I don't try it does not exist, no. I just say that I cannot give an answer for this. What do I need to do? More work. Hello, I come and I want to figure out what kind of more work do I have to apply here. There is one kind of more work that fits here. It's when we have fractions. You go ahead and simplify those fractions. Either add fractions, subtract them, take common denominator, simplify nested fractions. You know what nested fractions mean? It means when I have, for example, A over B over C over D, you can write it as AD over BC, and so on. So like all those kinds of things are things you can do with fractions that look like this. So over here, one of the things is I can try to take a common denominator for the goal of simplifying things. Now, as you have learned in pre-calculus or in schools before, if you have not taken STEM 1, STEM 2 here, if you come from direct entries from schools directly, you will know that if you want to take a common denominator for fractions, first you have to factor the denominators so that you'd see if there is anything in common. If you notice x minus 1 is common. What do I also need? X plus 1. This already has the same denominator, so I do not affect this term at all. This term has to be multiplied up and down by x plus 1 so that we can change it and have a common denominator that we're looking for. So this becomes 1 times x plus 1 minus 2. Here I do not have, I again insist that you use brackets. X plus 1 here minus 2 in brackets. You tell me, why do we want the 2 in brackets? Because see, if it was 2 plus x here, if there was a plus x here, and you don't put the brackets, then this minus will affect only what? The 2. What about the plus x? You will forget to multiply the minus by the x, and then your whole problem will get complicated. So please make sure that you use those brackets extensively. So now x plus 1, take away from it 2. When we take away, of course, we take away similar terms. So 1 and 2 are similar terms. X plus 1 minus 2 gives me x minus 1 over x minus 1, x plus 1. Do you see this? When I took a common denominator and sorted things out, look how different now my problem looks. Much simpler, much better. I can see where is the problem. Where is the problem? X minus 1 and x minus 1 are causing for me zeros up and down, but because we are approaching 1, not exactly 1, we can cancel this problem. So what do we have left? The limit as x approaches 1 of 1 over, do not forget the 1 over x plus 1, which is 1 over 1 plus 1, 1 over 2. All right, look at another example. Again, I try to substitute first. I substitute the 0. I get 2 over 0 minus 2 over 0. Whoa, again, I cannot answer the question 2 over 0 minus 2 over 0. I cannot answer such a question. So what do I have to do? I have to do more work. Because this is indeterminate. I don't know what it is. So in order to do more work here, I cannot miss that this is a very special kind of problem. What do we have here? An absolute value. This brings for us, who can remind me how the absolute value function works? The absolute value function of x is a piecewise function. It's made of 2 pieces. The first piece is it stays the same if we are already positive. If we are negative inside the absolute value, then what do we have to do? The x that is negative, I need to change it to positive. How do you change a number that is negative already into a positive number? You multiply it by another minus 1. So if it was minus 2, you multiply it by minus 1 again, it becomes plus 2. Again, I remind you for the second time this course that this doesn't only apply for absolute value of x. So I can have absolute value of x plus 7. I don't write this is equal to x if x is greater than 0. This is equal to minus x if x is less than 0. I don't repeat this story, no. I treat this all as the package. So over here, this is my package. Call it star if you want. So that you'd know it's not only x, it's any package inside my absolute value. If the package in total is already positive, it's already positive, you keep it the same. if it's negative as a package, you have to change its sign as a package. That's how you always think about absolute values, which means that over here, this becomes, it's equal to x plus 7 if x is greater than or equal to minus 7. You solve for x. It's minus x plus 7 if x is less than minus 7.